Knowledge is now worth zero.
How disruptive do you think AI is going to be?
It is the single greatest innovation of humanity ever. The only thing that comes close is probably the splitting of the atom. This is so big. Everything we've talked about is based on scarcity of knowledge. Why do lawyers get paid a lot? Scarcity of knowledge. So either scarcity of knowledge, scarcity of capital, those two things. What you've created is infinite knowledge. Right, knowledge is now worth zero. Not people that can't see it yet, but it's going to be worth zero.
Howdy, welcome back to my tiny corner of the internet. So in today's video, we're going to talk about how token costs are pushing the implementation of AI across the workplace, across industries to the brink. Is because for years we've been told that AI was going to take all the white-collar jobs, all the intellectual jobs, information, knowledge essentially became zero, and that AI was this tool that, was going to replace all white-collar jobs, and the only jobs left were going to be HR departments and blue-collar workers. And so it's been interesting to see how this play out, is because engineering was one of the roles that people mocked, for the last 4 to 5 years, saying that AI was going to replace engineering entirely. Now, obviously, I've talked about extensively on this channel that, there's no indication of that being the case. The Chinese are not even doing this. In fact, they have probably the most amount of STEM graduates in the world, and they're advancing in technology and engineering quite rapidly, and they still have their industrial base. But the thing is, we were told that it was going to replace the evil elitist engineers is because the engineers have essentially engineered their way out of a job. And that just somehow, no matter how advanced this technology is, if you carry this logic to its own conclusion, that if AI is really capable of replacing engineering, then why would it not go after other fields? That, never mind that logic. But the interesting thing is that, another problem is coming home to roost. Okay, I've said a couple of times on this channel is that I don't really consider AI to be a skill replacement. I consider it to be a skill multiplier, okay? A skill multiplier in the sense that somebody who knows what they're doing with an AI can use it far more advantageously than somebody who doesn't know what they're doing with an AI. Because the fact is, somebody who knows what they're doing, somebody who has the deep technical knowledge of whatever information they're trying to get out of it, whatever they're trying to generate, whatever they're trying to create, is able to verify the output as opposed to somebody who's vibe coding it. If somebody's just, prompting it saying like, oh, I want you to make this, they have no way to tell whether or not that output is actually correct, useful, or it's just a hallucination by the AI. And the funny thing about AI, one of my biggest criticisms of AI as well, is that I don't consider large language models to be artificial intelligence. I don't consider ChatGPT, Google Gemini, or DeepSeek really to be artificial intelligence. I consider them to be glorified interpolation machines. And so the main topic of this video was more or less getting into a tweet by, that was about Linus Torvalds giving his commentary on what he considers, to be AI. I've seen a couple of comments floating around on the internet that have compared large language models to compilers, and essentially is that when people were celebrating that, these large language models were going to replace, coders are going to replace, software engineers are going to replace engineers or whatever, right? The interesting thing is that when compilers first came out, right, the whole point of a compiler, at the time was to be able to allow people to write code in a human readable format that could essentially be translated to machine code. That was the notion of a compile-time language, like C or C++. These are languages that are designed to be semi-human readable, but a compiler will translate that to, hardware-level code, CPU code, something that can be run on an instruction machine on a CPU from RAM, okay? Every time you load an executable in RAM, it loads in the binary file and it executes, operational codes. Obviously, there's a scheduler and there's also other stuff that's going on through the operating system that kind of, is a middleman to the actual hardware. But nonetheless, if you were to use a language like C or C++, it can also be used to target bare metal as well. But the thing is that a compiler at the end of the day is a thing that translates human readable code into machine code. Okay, going from one level of low level code that's unreadable and it's hard to maintain to something that is much higher level that can be more easily maintained. And so, you've had levels of abstraction from one point to another, going from the low level stuff to the high level stuff, is because the field of computer science, if you go to any, and I'm not saying this as somebody who has studied computer science, I didn't take computer science in college, it was not my background, but the thing is, if you go to any computer science lecture hall or any kind of class you take with data structures and algorithms, very rarely will they, teach data structures and algorithms within a particular language. They'll use pseudocode, because what matters at the end of the day is not so much, the code that it's expressed in. What matters is the algorithms, the data structures, and the ideas independently of whatever language that you choose to express these things in, okay? And so, C and C++, these high-level compile time languages, which it's funny that C and C++ are referred to as low-level languages, and by today's standards, they kind of are. But the thing is, there was a time where it was considered a high-level language to program bare metal, hardware. And so the interesting thing is that there's been an increase on the level of abstraction to more human-readable code. And so, Linus Torvalds put out the interesting, point that compilers did not destroy software engineering. It allowed people to build more complex and sophisticated software by allowing people to write code in human-readable format. And so compilers, could essentially translate human-readable, information and code into machine code. And AI and large language models are really not that different either. It's because the fact is, if you look at the mechanics of large language models and how they work, the math that works behind it, and I've seen a couple of comments point this out, is that they're very similar to how compilers work. They really transcode things. They're glorified interpolation machines. And so when it comes to large language models, Linus Torvalds had put it like this, okay? It's something that is not necessarily useful on its own, but the thing is, it's good at transpiling things. And I've talked about a little while ago is because the fact is, if you can describe whatever algorithm that you want to implement, right? And, you want to implement something, you have an idea, maybe you want to make a triangle or rasterize, you want to use some kind of algorithm or whatever, right? And you want to implement it with a code base, and you know exactly how to do it, but you don't want to do it yourself, is because the fact is, you writing code by hand is very error prone. Why not get a machine to do it like an AI to do it for you? And so AI is very good at this task, is that if you're able to actually describe what you want it to do, how you want it to do it, right, and actually get those results, it's very good at transpiling like logical structures into a targeted language. You could target Python, provided that the language has the expression power to describe your idea. And so, Linus Torvalds made the interesting point is that large language models are not going to replace software engineering no more than compilers did, is because the fact is it just helped people to write more scalable and larger, code. Because the maintainability of something, the whole point of it, the point of like computer science, and this is from my experience, and I'm not somebody who studied computer science in college, has been the ability to express logical structures, on machines, to be able to express, broader ideas into this code. When I wrote, a couple of things, when I wrote that ray tracer and a couple other things, did I much care about the low-level languages used? Did I much care about like the low-level language like C or C++? It was, it was being expressed in. Did I really care about the details of the Vulkan API? Maybe the hardware acceleration parts on how it's organized through the GPU, just so I can actually describe the idea and actually take advantage of the hardware acceleration. But the thing is, do I care about these low-level details personally when I'm trying to implement an idea? Maybe to some degree. Maybe it's good to know the low-level stuff so you can know how to interact with it and express your idea effectively in that, but do you want to actually spend the time like writing all that stuff by hand? Well, no, I don't want to do that. I want to get results and actually build a ray tracer or something like that using hardware acceleration. And so the fact is there's an idea that I want to express, and, C and C++, and, using that Vulkan API is just, the APIs and language I wish to target to express my ideas. And so large language models and AIs are essentially this. Now, this brings an interesting thing, is because the fact is now we've hit a limit with AIs because it's bringing up an interesting dynamic. For years, they said AI was going to replace all the white-collar jobs. All the menial tasks are going to be replaced by AIs because AI is just fundamentally cheaper. And for a brief period of time, it did look like that AI is one of those things, and I've thought about it too, that you can use to replace all the menial tasks, all the junior level roles. Companies have been downsizing like you wouldn't believe. To replace as many junior engineering level roles so they can vibe code it away. Now, this is an interesting dynamic. This is something companies have been wanting to do for a very long time, and companies genuinely believed that AI was going to be their golden ticket to solve this particular problem that I've talked about in engineering for quite some time. Every time I've stepped on a job, no matter where it's been at, when it comes to any project or whatever, as an engineer, right, whatever project you have me working on, okay, there is a threshold of knowledge that one has to obtain about your project, is because this is how it goes every single time. If you're an engineer, you're going to recognize this stuff because you've jumped on between a workplace, right? It doesn't matter what project, what company, what team you jump on, but you're going to show up. You're going to know nothing about that particular project or product. And it's going to take a level of time or a certain amount of time for you to actually get up to speed, and I call it the knowledge investment problem, that every engineer has to actually go through, right? Every company has to go through, is because you have to have knowledge of the system to actually be able to meaningfully change it and add value to it. So for the first year or so, if you start off at a company, And, you go into a role and you start working on a company's project or whatever, right? There's a certain amount of time. And most of these, products that companies are producing are not simple. They're very complicated. A lot of the times it's never really a simple project. And so the thing is engineering as a field has always been a very knowledge and experience heavy field. Okay, the longer you've been with the company, the longer you've been working with the project, the more experience you can get on it, and therefore as more time goes on, you understand it better and you can contribute your own ideas better. Okay, this is called the knowledge investment problem, is because the fact is companies have been trying for ages, and this is one of the things that companies hate about engineers, is because the knowledge investment problem means that a company has to take the risk on hiring an engineer, and then sinking in a ton of money, whatever salary that may be, into actually, getting an engineer up to speed with their particular project every single time before they contribute an ounce of value to whatever product they're working on. And, if for whatever reason that engineer gets pissy and decides to change, teams or change companies, like after a year or two, that's a lot of wasted money and time on somebody who literally was trying to learn your thing. Like let's say you're an engineer, you work in a company, right? It's very unlikely that whatever product they're working on, whatever code base, hardware specs, PCB layout, board layouts, whatever, right? That you're going to immediately know what, the product, that team is working on, that company is working on. There's a period of investment, knowledge investment, that a company has to give you to invest into to understand their product before you contribute an ounce of value to their product. You can't avoid this thing, okay? And so the thing is that gives an engineer, or especially like any engineer, a tremendous amount of bargaining powers, because if they just leave the workplace, the whole project probably could collapse, and it's going to take years bringing somebody new off the streets to actually understand it and take that investment. But companies have always hated this, is because companies are very controlling. So are HR people, so are project managers, is because, they want results right this very second. They just can't imagine a situation where they have to actually put an investment towards anything. And the knowledge investment problem is a very serious problem when it comes to companies, and they hate it. They despise it. Because imagine you pay an engineer $120K a year, and they've been with your company for 2 years, and it took them about a year and a half just to actually get familiar with your project. And some companies try to speed track it to 6 months, but they can cope about that. That's never going to happen. It doesn't matter how well written your Confluence pages are and how well your documentation is. That's still information that has to be read through, right? And then, for whatever reason, they get mad and they decide to leave, change teams, or change companies, right? That's a year and a half worth of budget and salary you've just burned through, is because the fact is, you spent all that time investing into somebody and they just left. And companies hate this. This is why companies hate junior engineers, is because when it comes to training a junior engineer into a senior engineer where they actually get the workplace experience, where they can contribute value, that takes years, okay? And so it becomes like a game of hot potatoes for companies, okay? Companies are trading around, junior engineers is because they don't want to change, they don't want to train it, is because what if like that junior engineer gets trained up, they learn a bunch of things, and they go job hopping, or they get head sniped by another company. And so the fact is, companies have always hated training junior engineers, is because they don't want to be essentially the offset cost into training somebody who's just going to jump teams or jump companies, after a period of time. That's the knowledge investment problem that they don't like. But here's the problem. When it comes to the senior engineering pool, it's always retiring out, is because as that pool gets smaller, not only do those engineers get better pay, but also when they get better pay, they're quicker to retirement, they're quicker to age out of the workforce as well. So that senior engineering pool is always getting smaller and smaller. Companies will try to go to the senior engineering pool is because they want to be able to hire someone right off the street that can understand their product as soon as possible and just start contributing value as soon as possible. It's because they don't want to train a junior engineer. Okay. And so, but the thing is, the problem is, the conundrum is that, that senior engineering pool is always getting smaller. Now, these companies, when they invested into AI, they were banking on the fact that AI would not only replace the junior roles, but as LLMs got more advanced somehow, if they trained it more somehow, that eventually these LLMs would scale and effectively replace senior engineers as well. Well, it's turning out not to be the case. In fact, quite the opposite. All the people who are saying that these LLMs are going to replace the engineers, not only have they maybe, arguably, not really replaced the junior engineering roles, but the thing is, the senior engineering roles that they were expecting that LLMs would eventually replace are not going to get replaced either, is because the fact is now token costs are exploding. Is because for years we've been told that these AIs were going to replace every white-collar job under the sun. Obviously, engineering the first, is because the fact is, it's for some reason people have a hate boner towards tech workers these days. But the thing about it, when it comes to these tech workers and these senior engineering roles, and also on top of AI, is that these AIs, as much as they, said it was going to do these things, okay, if you actually go through it, and I came across another video that went through a very good and lengthy explanation on why, AIs are being more efficient than the human brain is fucking retarded, is because the fact is, fun fact, the human brain only needs 20 watts of power to operate in comparison to these large data centers that take up, megawatts of power, that take up and suck up so much water and power in the first place. Because who would have thought that venture capitalist tech bros were not actually able to outcompete millions of years of biological evolution, in human history, okay? Who would have thought that tech bros just couldn't compete against millions of years of evolution? But, that's kind of the funny part. If you look at it, the actual subsistence needed to maintain a human being is significantly lower than what these data centers, take up, right? It's kind of ironic. If you do the actual raw energetic calculations, animals do not take up that much energy. And that's the most ironic part, is because the fact is, Sam Altman went on a stage a little while ago saying that, you've got to consider what it takes to train a human being, and that in the long run, over the lifetime of a human being, that a data center would be cheaper than a human being. And the funny part is that's an interesting talking point, is because he thinks he's made little gazgotchas, because he's doing price, comparisons, and obviously he's still thinking in terms of venture capitalist investment money to burn through for his stupid little side project. But the thing is, if you do the raw energetic calculations, humans are actually significantly less energetically expensive than running these data centers. But the reason why humans are so expensive these days, that Sam Altman and obviously these rent-seeking parasites don't like to admit, is because why is it so expensive to be a human being these days? Oh, well, let's look at the housing market. The average house price is $500,000, and groceries are expensive as hell. And so the fact is, what it takes to actually operate a human being has been, propped up and increased in value so much, is because we have rent-seeking parasites trying to nickel and dime every necessity of life just for people to live. And that's what rent-seeking parasitism is. So the thing is, that distorts the cost of what it takes to actually maintain a human being. But, let's not get into the discussion of rent-seeking parasitism. We can talk about that all day, but that's not the topic of the video, right? But now we've gotten to the point where these data centers are not paying off. These venture capitalists are now doing margin calls or whatever, right? And they're demanding profitability from these AI companies, including OpenAI. And it's not exactly panning out as well as they thought it would be, is because the fact is, now token costs have exploded. Now, when it comes to, for all those years that they said that AI was going to replace white-collar workers and it was going to replace every menial task under the sun, now with the cost of tokens exploding, now people and companies are no longer incentivized to use AI willy-nilly. Now they have to be selective on how they use AIs, or if they want to do one internally, they have to make that choice as well, right? Now give me this one. This is where it's going to be kind of interesting to watch the dynamic of how AI plays out from here on out. Anyways, is because, now that companies have to be selective about how they use AIs, they can't just willy-nilly burn through AI tech bro money anymore. Now they have to be selective to it, right? And I've already said multiple times on this channel that AI is not a skill replacer, it's a skill multiplier, and that when it comes down to it, the people who use AIs, the only people who are going to use AIs meaningfully are those who know what they're doing. Do you think these AIs are going to be allowing people to willy-nilly spend tokens on people who are going to vibe code things that they're just going to hallucinate? And, some dipshit vibe coder is going to be like, well, ChatGPT, I need you to make me a game engine. No hallucinations this time. It's like 10 times in the chat. No, of course not. So the thing is now that they have to be selective about who to use these AIs with, they're going to de facto choose the senior engineers. And not only that, because they have to have somebody competent to actually operate these AIs, right? It's not the end of the road for them yet either, is because the fact is, when it comes to it, because of the knowledge investment problem that every company has to play, right? Somebody has to pay for it at one point or another, or you're just going to pay for it by paying, an overinflated senior engineer's salary who's going to be able to use the AI, right? So the thing about it is that when it comes to AI being used, it's going to be used by the senior engineers, but the thing is that pay is going to already really high in the first place. There's a golden handcuff phenomenon within engineering where the higher level senior engineers get paid a fuck ton of money, okay? That's a real problem, by the way. They're going to be really competent with AI, but when they make their money and they're done doing a bunch of projects and they've gotten their millions or whatever, right? They're going to retire out and never look in this field again, and therefore the senior engineering pool gets smaller. So the funny part is, even though they said, the reason why companies loved AI is because a lot of companies deeply believed that the knowledge investment problem was gone, okay? They believed that when it came to engineering, that these glorified chatbots were going to overcome the knowledge investment problem for engineering and destroy all white-collar work. These companies really believe that. That's why they laid off all their junior engineers, is because they believed LLMs would scale and eventually get rid of the senior engineers too, and this would solve the knowledge investment problem. Now, this is where it's going to be interesting, is because the fact is they might have just screwed themselves over, is because the fact is all the junior engineers that just got out of college, they antagonized for years, that they told them that, being a blue-collar worker was better than the jackasses and the evil elitist engineers who studied computer science or stuff like that. They dropped out of engineering. They went into blue-collar work. They probably forgot most of the stuff they learned in college, is because for years they were told that their engineering degree was going to be worthless in a couple of years. And so, now that we've gotten to this point, it's like these AIs have not fixed the knowledge investment problem, even though companies have jumped with glee that this would essentially remove the knowledge investment problem and that knowledge would be free. The truth is, when it comes to engineering or any kind of tech work, the truth is that when it came to engineering, any of this kind of tech work or any information heavy field, whether it be law, medicine, or engineering, is that the knowledge investment problem that you see with like junior engineers is that now they probably underproduced engineers. And none of this is necessarily new, okay? They've overproduced, they've oversupplied and undersupplied, different, work fields for the longest time. That's why I haven't really left engineering, is because the fact is I'm watching this train wreck go on in live, because the fact is now that the senior pool's aging out, they pissed off all the junior engineers, told them that their college degrees are worthless to go in the trades, and now that they did go in the trades, 5 years from now, there is going to be a shortage of engineers, is because the fact is, who went into engineering when they told them, for years, that AI was going to replace it, only to find out that it wasn't actually more efficient than replacing people? The token cost exploded is because venture capital started demanding profitability from these companies, and all these AI companies had to backtrack from all these things, right? That brings an interesting point, is because that senior engineering pool, getting smaller and smaller, means at one point or another, some company down the line is just going to have to bite the bullet, is because it's effectively just going to be cheaper to invest into hiring a junior engineer and recognizing the fact that you can't get around the knowledge investment problem. If companies want to get around the knowledge investment problem, I've got one simple trick for you to do it right here and right now. If you don't want the idea of having to train an engineer, you want to treat an engineer like a factory worker where they're replaceable and you can just bring them on site, force them to commit value, or, add value immediately, right? Here's one way you could do this, okay? The day that you can hook a wire up to somebody's brain and teach them everything they need to know about engineering in a second, okay, is when white-collar work becomes useless, when it becomes irrelevant. Not these stupid chatbots, because they have not been a substitute for actual human intellectual labor, but when you're actually able to upload these ideas, all these stuff that people have to study in college when it comes to engineering, fluid dynamics, electrodynamics, right, circuit analysis, all these things, when you're able to upload that directly to the brain in less of a fraction of a second, is when that labor becomes cheap. Is because the fact is the threshold of entry becomes incredibly low. And the funny part is, I was talking to one of my buddies who's in HVAC about this, right? He was talking about replacing like some busted relay or whatever, and then charging like $600 or something like that. Something, maybe it's a bit hyperbolic or whatever, right? And then, the customer gets mad and says, wait a minute, you only worked for 15 minutes. Why are you charging me $600 to replace something that only took 15 minutes to fix? And the HVAC guy tells him, well, it didn't take 15 minutes to fix. It took years of training to actually know how to fix that problem within 15 minutes. Is because if you try to do it yourself, you wouldn't be able to do it. It's no different with a surgeon, okay? When you're paying a surgeon, when you're paying a doctor so much, money, so they can actually do the thing, you're not just paying for that immediate diagnosis that takes 5 minutes then and there, okay? You're paying for the years of training and experience to actually be able to fix your fucking problem in the first place. And engineering is no different either, okay? And so this is what the new AI dynamic is really bringing out, is because the fact is, A, it didn't replace all the senior roles. Now AI is starting to downsize. Token costs have exploded. And so the fact is, I've also noticed a ton of companies are starting to quietly rehire people, is because they're recognizing that if anybody wants to be able to, if they want anybody to maintain their product, a glorified chatbot isn't going to be able to do that. Is AI going to go away forever? Is AI going to disappear when the AI bubble pops? Is it going to disappear? No. But I think 80% of the hype around AI that people are doing right now, integrating in the dumbest fucking places where it doesn't even have any relevance whatsoever, 80% of where people are saying AI is going to be useful is not where it's going to be useful. There's a very narrow, useful 20%. I think it's going to be useful in a lot of future software development, fields. I think it's going to be useful in mathematics. I think it's going to be useful in a couple of things, but as a tool to enhance somebody's already existing skill set. Are they going to create pipelines where they're going to use AI to basically transpile logical structures into like hard written code? Yeah, I do that myself sometimes, because the fact is sometimes it's better to tinker around with ideas and then transpile it to a language after the fact than it is to necessarily get stuck in the weeds of writing in a particular language in the first place. Looking up API documentation, figuring out how an API works, figuring out how a language works. You know, that stuff is so boring. I've never really cared about writing code particularly myself. I've always been more interested in expressing ideas in code, and AI seems like it's going to be a very useful tool to do that, where you can actually focus on the idea and the high-level stuff as opposed to the low-level stuff. And I've said that before. I've said that in earlier videos that I don't see AI replacing, you know, the higher level, you know, critical thinking roles. Is because the fact is, at the end of the day, when it comes to these fields, when you're working as an engineer, your job is to solve problems. You're not necessarily there to be a memory textbook to remember everything. You're there to come up with unique solutions to fix problems. And that's all it is at the end of the day. And I think AI has its role when it comes to the workplace. I think it's going to do a lot of things. It's already helped me in a lot of instances on stuff that I've written to make it easier. Unit tests are something that I use AI to write most of my unit test for, because the fact is, if that's a clear, concise, like, you know, concrete problem that you can tell an AI exactly what to do, what to test, how to test it, and, you know, it'll do it pretty flawlessly, and you can verify the output. I've always hated writing unit tests. I always have. I never will like that stuff. And so that's something I like to automate away, is because I don't want to spend thousands of lines of code, you know, that is human fallible, where I can make a mistake typing something, when I can just get the AI to validate it for me, and then make sure it's actually consistently giving the right output. With that being said, I think I've given my thoughts on AI. I don't think AI is going to be replacing anybody's jobs. Will there be a similar downsizing? But I think it's going to be just like Linus Torvalds said, is that AI is not necessarily going to replace people the same way the compiler did. But did it change the way computer science was done? Absolutely. People are not using punch cards to program anything anymore. They're using compilers, they're using laptops, they're using higher level language to describe ideas, and then compiling it down to lower level stuff like machine code, okay? And AI I see is no different than that, is because the fact is, even though it's funny that, you know, we consider C and C++ to be a low level language today, there was a time, you know, many years ago, many decades ago, where C and C++ were considered high level languages, is because before that you had punch cards, and you had to write in opcodes and binary and machine instructions. And the thing is, that's not very easily maintainable or human readable. And so the idea of higher level languages replacing lower level languages was just an extension of the idea of, you know, being able to abstract upon, you know, the hardware, the lower level stuff, to be able to express ideas more easily. And that's what I see AI doing, is because, funny enough, the structure of LLMs is very similar to how compilers work. They're essentially very similar. And so the thing is, I see these AIs being very useful for transpiling things like higher level ideas to lower level languages like C and C++. It's a similar jump. So that's my 2 cents. That's what I think AI is going to do in the future. That's how I think it's going to be integrated in the future. You're free to agree or disagree at the end of the day, because at the end of the day, you know, everybody's allowed to believe whatever they want, okay? So if you enjoyed this video, don't forget to like, share, and subscribe, and I hope to see you in the future videos. Peace, peace.